Well, hi everyone, and welcome to Edmonton Pass for June 2024. We have Wilson Mock going to speak about Azure Synapse and Analytics and Serverless Spark, I believe. And I posted a little something about the Pass Summit in November in Seattle, which is always a great thing if you're able to go. Wonderful time and lots of learning. And thank you all. So without any further ado, I'm going to walk all the way over there and we can get going. Thank you.
All right, sounds good. Well, hi everyone. My name is Wilson Mock, and welcome to the presentation today on conducting data analysis using Azure Synapse Analytics. So in this sessions, we're going to explore the fundamental of conducting data analysis using Serverless SQL and Serverless Spark. But before we dive in, a quick introduction about myself. Wilson Mock. I've been working in IT for over 20 years. I started my career in software development prior to joining the data space. I'm currently consulting at SMS Equipment as a data architect. So previously, I worked at Avanan as a manager of data engineering, lead data architect at CAE, as well as a lead AI architect at Air Canada. So I'm also a Microsoft Data Platform MVP, as well as Databricks champion as well. So yeah, if you'd like to follow me, I can be found on LinkedIn, GitHub, C#Corner at /Wilson-Mock. So with that, we'll dive right in. As we kind of alluded on it early in the conversation there, we'll do a quick introduction of Synapse Analytics. And if for those of you that have used the Synapse before, it'll be a quick review of what Synapse is. And we'll focus our discussions today on the serverless SQL as well as serverless Spark, and we'll dive more in detail around that. Then the next topic we'll cover is to explore the importance of data analysis. Why is data analysis important? Why is having accurate and relevant data important to us and as well as for the business that we're working with? And lastly, we'll go through two demos, one with Serverless SQL and one with Serverless Spark. And we will be going through the data analysis steps that we are going to talk about in step 2. So for the audience here in this session, you'll be beneficial. You guys have some knowledge of SQL. If you guys have Python experience, that's great. Not required, but it's nice to have as well. In terms of the structure of the presentation, we'll go over a bit of the theory or the concepts first, and then we'll dive into a demo. After the first demo, we'll have a quick Q&A session, followed by a longer Q&A sessions at the end of the presentation. And all the code you guys see will be available to you at in my GitHub repo at the end of the presentation. I'll have a link available as well on that. Okay, great. So with that, we'll jump into Synapse Analytics. So Synapse Analytics is an enterprise analytics service that integrates big data as well as data warehouse into one single service. Really, it has two primary components. The first one is the data integration. So that's your data pipeline, your orchestrations, your monitoring. This is essentially the same as Azure Data Factory, if you have used that before. So you can build, monitor, orchestrate your pipeline using a lot of mainly the built-in connectors that's provided within the data integration tool. So you can see on the left-hand side of the screen there, that includes bringing on-premise data. If you have any cloud data like Azure SQL, or if your organization connects with any PaaS services like Salesforce or SAP, they have connectors for all of those stuff, as well as if you're doing streaming data as well. And the main purpose there in Synapse in the middle here is to take all of this data, process them, aggregate them, and then send it off to the target, whoever the consumer would be. And the two primary consumer we have is Power BI for your reporting, which is the traditional data use case that a lot of us are familiar with, but as well as Azure Machine Learning for those that are want to train their machine learning model as well. So that's the first component we have. So the second component, which is also the bigger components of the two, is the analytic runtime. And that's broken up into three different separate runtime mechanisms. The first one is SQL on the screen on the left, also known as Synapse SQL. A lot of us, probably if you're from the Microsoft space, T-SQL is Transact SQL is familiar to you. So within that, there is the serverless and a dedicated option. So the serverless option is primarily used for ad hoc queries or analysis primarily. We could do some data processing in there as well, and we'll kind of talk through that a little bit as well. The dedicated option is similar to your traditional data warehouse that we have. So, we got your on-prem or you're new to the cloud with the previous version of Synapse, which is SQL Data Warehouse, that would be the dedicated version of that. And what that really means is you can specify the performance level that you want your data warehouse to be, and you're essentially paying for that performance level during the database uptime. So you can also start and stop the database as well, in case if you need to do any of that. So when you have a large amount of data set that you need to serve to the business and or allow them to query, at their convenience, dedicated might be a good use case for that option. Depends on the data volume, of course. On the Apache, the next runtime is Apache Spark. So that's the big data engine, if you're familiar with Spark itself. So in this case, it's a flexible engine that can handle a range of workloads for us. So that's including things like the conducting of data analysis, which we'll look into today, preparation for the data, transformation for the data, and also machine learning. So essentially, a lot of the ETL heavy lifting is done, can be done in Spark as well. So finally, the Data Explorer is the third item on the analytic runtime. So that is a preview item that's been in Synapse for a few years now. And it's mainly built to handle time series data using a language called KQL. So if you're analyzing any Internet of Things, IoT data, telemetry, or even log analytic data, let's say your website has any traffic data you want to analyze, that would be a good use of this tool to kind of monitor how your customer might be using or behaving. Now, the last item we're going to touch on quickly is the data storage at the bottom of the box there. One of the main benefits of adopting Synapse is that it has the integration with the data lake storage in mind. And you can use SQL as well as Spark to work directly with the data inside the storage accounts. And that's really the foundation concept of working with big data. Your data is stored in the storage accounts, and you take your computation, however it needs to be in SQL or in Spark, to analyze the data and to process the data, essentially. In the next two slides, we'll talk more about serverless SQL as well as serverless Spark, as that's kind of a focus for the presentation today. But if you have any interest in other area, let me know. We can work with Brent and team to organize future sessions on those topics as well. So with that, what is serverless SQL? So we kind of touched quickly on that in the previous slide, but what is the really main benefit of serverless SQL? So the key concept here is the serverless SQL enables Synapse to query our data in our storage account efficiently. In the traditional data warehouse, when you have a file coming in, you would have to read that file, parse that file, write it into a staging table normally, right? And then, maybe a DBA needs to be involved, a data engineer might need to be involved, or like a SQL developer needs to be involved before data can be made available for the analyst. That's a quite lengthy of a process for us to go through. And with Synapse, we kind of remove that barrier to go through all of that parsing, and the engine will do that for you. In addition to that, main challenge with Spark was not everybody knows the language that they have, even though they have quite a bit of flexibility. But one of the draw is that we can leverage SQL or the Transact SQL commands that we're familiar with for most organizations that have SQL expertise or they're coming from SQL servers. So some of the commands that you're familiar with for the DDL could be, You can create a drop databases schema, you can create views, create tables, store procedures, etc. But one thing to note is that the tables that we're defining in the serverless SQL database, it's actually external tables. So we did use the keyword external table instead of calling it just create tables. And that's because the table or the data is actually stored in the storage account itself. Microsoft added this new keyword in order to differentiate between external versus a table that are stored inside the database. For serverless SQL, you cannot create an internal table, but a dedicated you could. So dedicated, you can do both external and internal tables. And so that's the minute difference there. Then the next thing is the DML, of course. So we can do select, but we won't be able to do updates or insert. An alternative to that is you can use create table or select, but in this case, of course, it's an external table. So we got to add the E in there, is CETAS in this case. Yeah, so the final benefit we have here is the serverless SQL in Synapse will automatically scale the computation based on the amount of data you're working with or your query that you're querying. So in the case of if you're doing a simple join versus a complex join, the complex join Synapse itself will automatically utilize more compute to calculate the results for you, giving a reasonable time to return the data. Where in the traditional model, you're locked into that performance, whatever that the number of CPU or number of RAM you have, that's what you're working with. And because Synapse is handling all the scaling up for you, cost is now become a concern, right? So in this case, for the serverless SQL, Synapse charges you based on the data processed, not the amount of uptime that serverless SQL is available, right? You don't know, there might be 5 compute, there might be 10 compute underneath it. You don't really know, and Microsoft is the one that manages that for you. So serverless SQL, the server is always available for you to use, and you don't have to pay for any of the standby time that the compute is available there for you. Only when you run a query, you have to pay for that time itself. Okay, now switching over to serverless Spark. So the key concept here is serverless Spark gave you the ability to process large amounts of data in memory. You call it cluster of VMs. And this technology is built on top of Apache Spark, and Apache Spark framework dictates how you manage and distribute the workloads across multiple machines. So the next benefits around that is it supports multiple programming languages. It's quite flexible. You can do PySpark, which is Python Spark, Scala, which is Java for Spark, Spark SQL, and Spark R. Spark SQL is a little bit different than the SQL Server SQL or the T-SQL. It's more support basic SQL that you would do. So in Spark, we develop using a notebook or Enact notebook in this case. So it's similar to Jupyter Notebook if you guys have used that before. If you have not, a notebook essentially is a bunch of cell blocks that you can write your code in, and you can execute them either one by one or execute them all of them together. Another benefit of the notebook is that multiple users can work on the notebook at the same time using different languages. So I might be the one that's really loves SQL, but then I have a colleague that knows Pythons really well. So we can both mix and match our languages within one notebook so we can achieve the goal faster. Another benefit of Spark compared to serverless SQL is that we have a large library of extension that we can apply to Spark that will make our work a lot simpler. So some of that, for analysis, we could be using something like a Panda or NumPy. For visualizations, we might be using things like Matplotlib as well as things like Plotly. There's thousands and thousands of libraries out there, so those are just a few for examples. And as I mentioned earlier, finally, there's also the machine learning pieces that can be run in Spark. Things like scikit-learn and PyTorch can be run there as well. Lastly, for the cost, right? So for the serverless Spark, we do have to build the cluster ourselves. So we need to specify how big of a clusters do we want, small, medium, large. And we also need to specify the number of machines we want to use. It does provide the scaling, but you need to provide the min and max there. And because you're paying for the machine that you're being used, when your cluster is active, it is very important to specify a shutdown window or like a timeout window. Traditionally, depends what you're doing, that window can be between 15 to 30 minutes. And if you're doing more user ad hoc analysis, 15 minutes, right? You don't want to keep that up all the time, but if you're doing some kind of long analysis that might take a long time to run, we might want to set that up to a higher amount.
So this is defined in the cloud, in Microsoft's cloud, right?
That's defined in the analysis service UI. So you can go into the configuration screen and create the cluster.
Okay.
Yeah.
And I guess we're jumping into.
No, that's fine. We can. We cover quite a bit of material, so it's good to ask a question.
Period. If you I start a big query and I think, oh, this will only take 5 minutes, but of course it's going to take 5 hours. Does it kill my session after the 15 minutes, or does it kill it after when it's done?
That's a great question, Brent. So no, so the timeout period will start when the machine is idle.
Oh, okay.
So you will run the 5 hours, then tack on 15 minutes on top. Now, you brought up a good point though. There has been runaway jobs that people run for 2 days. So you set a timeout period, but people need to be aware that if the job is running a long time, and they need to be mindful that that is costing a lot of money. Potentially.
Can you run some sort of monitor on that then?
Yeah, of course. So there is monitor either inside the Synapse Analytics if you're an administrator, for example, or using log analytic, you can probably see some of those informations as well. Any questions online there? Feel free to type in any questions you guys have as well, if you guys have any. Okay.
And Spark is kind of similar to Hadoop, right?
So Apache Spark created as part of a research project at UC Berkeley to address the limitation of Hadoop. Hadoop access to the storage accounts each time you execute a command, and that causes a lot of slowness. So Spark was created because it processes the data in memory, which allows a faster processing time. Later on, the researcher has co-founded a company called Databricks. Okay, so if we're good, we're going to continue on. So now, imagine a time when you tell a client that you create a report for them and the number doesn't quite match, right? It happens all the time. It happens to me. And you get someone calling on the phone, yelling down the phone. It's like, why isn't the number that doesn't match the report I need to give to the executive or the manager or whatever not? And that's the scenarios that we run into all the time in data engineering or data analysis. This is quite frustrating and overwhelming because you might be asked to have quite a quick turnaround to resolve the issue, and you might not know what the issue is. You might not even be the one that built the report for that matter, right? So this is quite an uncomfortable situation to go find out why. Some of you might be excited having this opportunity to go dig into a report all of a sudden, but it could be also stressful. I think the main takeaway we want to have is, at the end of the day, this kind of problem loses trust with our business and with our clients, and more importantly, also loses the trust in but the process that we build in place to help them not have to revalidate every data all the time. In order to make sure our data is accurate and have to go through certain rigor to validate our data, right? Before we go build any reports or use it for any machine learning model. At a high level, this is a 4-step process. So the first step is, of course, we need to retrieve the data. Now, ideally, the data will be landed on our desk when we need it, but often when we first look at a brand new data set the business asks, often we have to be the one to go extract the data, right? And that might be from a database, that might be downloading it from a public website. If we're working with public data, like the weather data, for example. And then we need to upload this data into the data lake. As we mentioned earlier, all of the analysis we do, the data starts at the data lake, right? As both serverless SQL and serverless Spark architecture depends on that. Now, the next step, we need to build our understanding of the data. And that really broken down into 2 separate aspects. There's the technical portion of the data, and then there's the contextual or the business meaning of the data. For the technical aspect, we want to understand the data format that we're working with. Is it a CSV file? Is it a database table, Parquet, XML, or even things like semi-structured data like a JSON file, which traditionally we might have a little bit difficulty with that in the traditional SQL Server model, but it has gotten better in the last few iterations. The next thing we need to also handle the data structure. For XML and for JSON, the data can be nested, right? So you have data structure underneath data structure, where in a CSV file, everything is a flat table, just like a database. We need to worry about data type as well, like each of the column type is a number, strings, varchar, datetime as well. And the last technical aspect we need to worry about is any constraints on the data, primary key, foreign key, unique columns, etc. So a good example of that is, you might have multiple columns that build in your your uniqueness definition in the database. So you need to make sure, for example, each account has only one unique email address, right? No one can reuse the email address. So that'll be a good example of that. Now, the next thing we need to do is to understand the context of the data. A good example of that would be if you're working with a table that's storing weight, right? Is this in pounds or is this in kilogram? They can mean different things. Is the whole column storing the data, are they consistent across that unit of measure? More importantly, for the financial data as well, sometimes we work with data that has taxes included, sometimes they don't. What is the currency in the data? Do we have to deal with any currency exchange as well? So those are key aspects that we need to understand the data before we dive into the actual analysis of the data itself. Right, so now we have the understanding of our data. Now it's time to really dive deep into assessing the quality of the data. And this is a very crucial step. This is where a lot of the data problems we find in our reporting and as well as machine learning analysis. To assess the data quality, there's really 6 metrics we're trying to measure. And we'll go from clockwise all the way around. So the first one is accuracy. So we need to make sure that the data is correct. Do we know if the source application having the accurate information that we need? Do we have any gaps or misunderstanding of the data? Really from the technical perspective, since this data comes from another database or another data source, we can really only do row counts to make sure the extract that we created is the same as the source table that we're extracting from, right? And so that's the accuracy, that check that we commonly do. The next one is completeness, or what I call generally just a mandatory check, mandatory field. So any columns that have mandatory fields to it, but also important to know that there might be business logic that are implemented in the application that drives the mandatory fields that are not in the database. So it's not just everything that's in the database, it's also had to talk with the business to figure out what that looks like. So this includes things like, of course, naturally the not nulls, that's constrained on the database, but you can also have empty strings, or you can even have user try to bypass the mandatory fields if it's a string by putting empty spaces, right? So we need to make sure we check out all those things so that the mandatory field that we expect the data to be in is actually there. In the cases of CSV file that we have, we need to make sure we take care of all the escape characters, as you don't want your columns to be shifted or truncated any data that might not be there. That's a very important note there, because a lot of time you might go through a lot of analysis finding a lot of errors, but it turns out to be escape character that's causing you most of the problems. Validity, so this is make sure that you have valid date range, valid formats for your data. An example would be a date format. If you have multiple date format in your data, you need to make sure the year, month, date, format that you have consistent across all of your columns that you have, right? So that would be a good example of that. Consistency, so this would be making sure that the column or the data set has the same meaning. So we talked about, let's say, the weight example that we use, right? Is the value always going to be kilogram, or do we have a unit of measure columns that we need to combine both data with to make sense of the data? Another one that it's important if you're working with time-sensitive data is time zones. MST, MDT, right? Daylight saving, standard time, as well as are we using something more universal like GMT as well? That changes the meaning of the data. During daylight savings, you might see the daytime skipped an hour, or the same hour appear twice in your data, which might be kind of confusing. The number 5, uniqueness, talked about earlier. We should have one email address per account. So the email address being reused, this could be an issue. So we want to make sure we find all those duplicates if this business rule exists. And finally, timeliness, and that's a quite important aspect of data quality checks, as we want to make sure the data that we have is current and have enough sample size for the data that we are trying to build understanding of. For things like seasonal or trend analysis, we usually need multi-year of data to really confirm that trend. But even for monthly reporting, we want to make sure we have a year worth of data. So we catch all the high and lows or any variant that might come in from different months. So the next natural question would be, what do we do when we find all those errors, right? So During data analysis phase, really, we need to work with the business to figure out how we want to handle this. This could be the business might need to go back and fix all the data that they have, will require us to restart this process of data quality checks after we have the new data set in hand, or we might choose to reject those data that we have and continue to the next step of our process. One word of caution there is if we do reject any data records, we need to watch out for data skewing. So what that really means is if the data are clumped together into a specific time period, you might see like a significant drop off of financial data, for example. And that's something we need to be mindful of when we do that with the business, so they don't all of a sudden see that their revenue dropped off, by 50% or something dramatic there. So the last step we have here is actually the creating the insights on the right. Distill all the data. We need to create some quick visual to confirm that with the business, what they're asking us to do. We can provide that with the data set that's being created. For some simple example, we might be doing that inside of Synapse, which is what we're going to demonstrate in a moment here. In the case of when we have a really complex or big project, we might even go as far as creating a Power BI reports for the business to analyze. But the idea here is try to keep it as light as possible, because you don't want to spend a week building a Power BI report and then the business turn around and say that this data is actually not what we need, right? So the suggestion here is keep it as light as you can if possible. All right, so with all of that concept out of the way, we're going to dive into the first demo, which is with Serverless SQL for the data analysis. I have already copied the data into the data lake itself. So we're going to use the New York yellow taxi data set, which is a common data set that people use for examples and demos and so forth. As we talked about earlier, we need to first create the external table based on this data is already in the storage account. And then we're going to look at this data, build some SQL query to understand the table structure, both on the technical side and take a look at the contextual, the business meaning of the data. We're going to go through a few data quality checks. It won't be exhaustive, it's just a sample base that I put together to check the nulls, the max and the mins. The goal here is really trying to exclude any data that doesn't apply to or doesn't seem quite right for the data set. And then finally, we're going to create a quick chart. All right, so with that, we'll jump over to Synapse. So this is the storage account that I uploaded the data. So in this example, there's only one file, contains this data. This is about 174 megs. Just be mindful that in GitHub, they don't allow me to upload a 174 meg file. So this is actually broken up into 4 files, which we can still read. It's not a problem. It's just want to make notes of that, as we won't be able to upload the whole file at once. All right, so in here, for the demo one, there's 2 files that we're looking at here, the first 2 files that are opened up. And this essentially is going to go through some of the steps that we talked about. For the first few steps here, I'm just going to quickly run them, because we're just going to create a database and a schema for our analysis, and there's really not too much exciting to see here. It's more the technical aspect of it. So the next step here, we're going to create external file format. So this is the Parquet file format. It's an open source file format that's used very commonly in the big data world. Essentially, a Parquet format is we store the data by column, and we also have compressions built into this format. And it also supports the nested structure that we might encounter in some of the JSON format that we're working with. And then the next line here, the next command here is, again, it's probably one of the last lines that are more technical in nature, which is creating a connection to the storage account. As you can see, there's no authentication being passed in here. That's all done through RBAC authentication with the person that you're signing us. So for myself, this demo user has to have access to the storage account files in order to access the data yourself, right? So admin might create this connection, but that doesn't mean that anyone can query the data. So with that, we're going to run this next command, which is selecting the first 100 rows of this New York taxi data. Again, in the case of if you want to run this demo yourself in the future, just change this name to a star and you'll read more than one file. Yeah, I found that out earlier today, so I didn't get a chance to change all the scripts. But in any case, so we can see the data that's being produced. There's some vendor ID, we get a pickup drop-off date. So there's a few interesting information we want to see, right? So the first thing, as we're scrolling across this, we notice all the lats and the long or the geo data are empty. We don't quite know why it's empty at the moment. Maybe we don't want to use it, maybe it's not being used, we don't know. We also know that this data is for 2019 January. So it's good that we see the year and the month is January 2019. We see some smaller amounts of payments, and there's some passenger information, distance information that we have as well. It's a little interesting that, the distance is 1, right? Maybe this is 1 kilometers, maybe this is 1 miles, and maybe that's okay, right? We don't know at the moment, but a few things important to note. So the next thing we'll do is create the external table so that we have an easier time querying the data, right? We don't have to always dragging this open row sets around in all the commands that we have. Again, with external tables, we always have to provide a location where we read the data from, the data source, and then the format the data is stored. So in this case, it created the table, no problem. And the next step here, I just want to show that when you create an external table or select, this actually copies the data. It doesn't generate the table based on the data that originally located. So if you run this command, will take actually quite a bit of time to run in this case because you're actually copying the data into a new storage location. So in this case, I'm writing it to the demo copy data location, a folder in this case. Okay? As you know, when I'm writing out this location, I don't provide the name. This is getting generated by Synapse itself. That's the common practice. You don't really provide the name of the file, right? Yeah, so this probably take about a minute to run. When it's done, we're going to run the last command of this notebook, which show you the external table that we query the data from.
So what happens with bad data in your data set in the Parquet files? So if you had text in a date string.
Yeah, that's a great question. So since this is a Parquet file, there is a schema already defined. Okay. So we avoid that problem. But if it's a CSV, then yeah, you definitely have to look through and be more careful about what that looks like. There might be a lot of implied conversion that might take place, right? You might not be able to create your external table if your column, let's say you forgot to identify the escape characters, for example. Yep, so with that was the first part of the Serverless SQL demo. Now we're gonna go and jump into analyzing the data itself. So the first command here really just switches over to the database that we created a second ago. And the second command here is, again, this is the same query that we saw at the end of our last quote script, which is just have a quick look of the data that you created. There should be no surprises there. It should be exactly the same as what you saw earlier. Now, for the accuracy check, we want to see the number of rows that we have in this data set. In here, it looks like there's about 7.6 million records. So if we have a quick look over at the New York taxi trip data from Kaggle, it will tell us that there's about 6.67 million record as well. That seems to match up quite good. Now for the completeness check or the mandatory check, we're going to check all the columns that based on the reference information provided to us if there's any nulls on those columns. For example, vendor ID is a null. The pickup drop-off time, since it's taxi, you expect be picking up and dropping off customers. The year and the month this data belongs to. Hopefully you have a passenger in your trip that you have and distance you travel. And the most importantly, you got to get paid. So this is the making sure that the fare amounts and then the total amounts is also available. So none of the columns are null, none of the rows are null, which is a good sign. So we pass the first check. Now, as we alluded earlier, this is a taxi service. But interestingly, we see that there's 0 passenger in some of the rides. Now, that's interesting. We don't quite know why yet, but it's interesting. And we have as many as 9. So maybe this is a big, fan service that the taxi service provides. And then we're gonna check the fare amounts, right? The min and the max fare. You hope you're making money from the fare. It's weird that you have a negative $362 as a fare. I'm not too sure why, but more exciting is there's a fare that's $623,000. So that really intrigues us. Like, is this number really right, or something
people around the world 7 times? Yeah.
Right.
I'd like to see how you're going to pay that.
Yeah.
I don't think my credit card would take it.
So yeah, which is why it's important to take a look at all this data. So the next thing we look at is the trip duration, right? So you're picking up a passenger, you expect you travel X amount of time and you're dropping them off. If there's any record that yes, your pickup time is bigger than your drop-off time or equals to, that means either you travel backwards in time or you didn't travel at all, right? And we see a whole bunch of data here. Now, you might have trip distance 0 might make sense. It might be okay as a record, maybe just a empty record coming through the system, but you also charge $2.05. So something is not quite adding up here, right? Our data actually goes all the way to seconds. It's also important to note that sometimes we might have daytime columns, but we don't actually measure down to the seconds, and we might be just driving a block down the row, and that might make sense. But in this case, we do have seconds, so that doesn't make much sense at all. We also have passenger zero, pay out $25, which is also really weird. So we're doing a lot of intricate things that this shouldn't be happening logically, right? So of course you go talk to the business to figure out what are those record means. Are they just issues? Or?
Your query would do better instead of greater than or equal, but equal show you ones where
the start and drop off time are the same. Yeah, which is weird.
Especially when you go into the second.
Yeah, that shouldn't happen, right? So
you see the top one there. It's exactly the same time, isn't it? Both of them, in fact, all three of them there.
Exactly. So we're finding a lot of problems with those data. Now, what do we do with them, right, essentially? So I think we have one more check here before we dive in what do we do with them. So check the year and the month to make sure that all the data is January 2019, as we talked about, for the timeliness check. Now, if you're doing the analysis for your business for this calendar year's data, hopefully that'll be in 2024, 2023. But for the example we're running through, the business is interested in 2019 data. There's a lot of different issues going on with the data. And ideally, we want to create a clean data set that we can do our analysis of. So this is not much different than the traditional concept where you have your staging table and then your actual data table.
Those first queries were your idea of what could be wrong as against the user's
understanding.
You're looking at very basic things like if 0 passengers, haven't taken any time. So you'd have to go through a second stage where the user is involved and say, well, this doesn't make any sense to me, whereas this is saying, well, this doesn't look good anyway.
This example here, it's quite simplistic in nature, but definitely you bring all this information back to the business, like, hey, what do we do? Right? Are those wrong? Do we have more complex scenarios we need to check? And essentially, all of this check that you're doing will fall down to the data engineering for your processing later on that you can run repeatedly. But right now, it's very hands-on, building those checks that you need to figure out what those are first. So based on the Kaggle data set, we also noticed there's some column type differences. So when you create your final clean table, you need to make sure you cast the data into the right type. Now, I know I didn't show the data type that provided in the previous screen, but a lot of them were varchar as what the initial interpretation of the data coming in from the Parquet file. Unfortunately, at the beginning, when you create the external table, you have to match the type with what's stored defined in the schema of the table. But now this is the time to fix it, to make sure they're correct. Okay? So again, just like before we talked about when we're doing a create external table as select, this actually copies the data. And we want to write this to the clean _ New York Yellow 2019 January folder.
So your first raw data set was 174 megs. As you're making these clean data sets, it's creating a copy. 150 megs.
Potentially.
You're now spending 225 megs of storage, right?
Right, yeah. So the storage cost is usually relatively minimum. It's the processing cost, right? So in this case, they process all 175 megs of data, and that's what you're paying for, even though you're only writing out 150 meg of data, right? Okay. So we scan 184 meg of data, and then we write out X number of record back out. Okay.
I thought originally we had 6.6 million. That's
double check here. 7.66, I believe. Not a big chunk of data got removed, which is good. We don't want a big chunk of the data to be removed, right? So the next thing we're going to do, just demonstrate you can create view of the data. This is going to be a really quick query because we're just creating a view, which essentially we're just summarizing the data based on the average number of trips for the day of the week that we want to analyze. And then we can run the view because it summarizes the data, right? Query will take a little bit of time to run. So we see all of this data. We can also just quickly chart this. So if I were to pick the day of the week, we can also pick the difference between the average number of trip per day and then the number of passenger that we get on average. Cool.
Yeah. Saturday night and Sunday mornings you have more passengers and
Yeah.
people going to work, you tend to be fewer.
Yeah, and then Thursday actually there's more people taking the cab than any other days.
Yeah.
So yeah, so that's kind of the quick demo. So you can save this as an image, give it a business. You might do a few more different charts or analysis you want to do. You might choose not to create a view for that matter, right? Like for me, just simple to create a view and demonstrate that. But you might choose not to create a view and just run the queries, and that's fine as well. Not restricted to the method there, as long as you save the script that you have. That's the most important, I think, takeaway there. Okay. Now we're going to jump into the first Q&A.
So the data that was excluded simply wasn't selected from the first data set to the second.
Right.
Like it doesn't go in a special bucket.
Yeah, so we could. So we can reverse all of the conditions, right? Or even do a subtract. Okay. And write it off to a separate table. Now, we would do that in the engineering space where we would find all the error records, indicate them, mark them, and then tell the business those are having errors. But in our first initial analysis, we just try to make sure the data drive the right insight. So that's why I didn't write them to the secondary table, which, yeah, you should if you're in those scenarios. So yeah, so we'll continue on to the serverless Spark demo, which is pretty much the same demo as we just saw, but we're going to be using Spark. The two main differences are that instead of creating an external table, Spark we create data frames, so that's store the data in memory. So the outcome of that, we are actually creating what we call a lake database, which is a concept of combining data lake or storage and a database itself. There's also extension packages. We can do deeper analysis with statistics and things like that, which we'll quickly illustrate in the demo as well. So now we'll jump over to the Spark here. The first command here is for cleaning up. So I'm just ignoring that command for now. If you guys want to rerun the demo multiple times and want to restart that, uncomment that command out. So the next command here is we're going to load the data from our storage. So again, exact same location as we saw before. Again, if you want to run this by yourself, make sure this is a star instead of the name, as GitHub won't let me store data of that size. And what this command really does is tell Spark to read the data, and we also want to display the first 10 rows that's available. So the next thing here is we want to show the data type as well.
Are you expanding it that put them in sequence to run, right? Because I'm looking, you click the first one, and then you're into the second one, and it says waiting, and there's a time.
Yeah, so this notebook, they run in orders, right? On the command that you ask them to run, or you can just run them all. I'm just preemptively telling them to run as soon as they're ready. Okay. So now data's starting to come in, right? Now we can see the data that we saw earlier, and now we also get the columns that we were checking earlier, right? So this vendor ID is supposed to be a int, but it's coming in as a string. Similar issues that we saw earlier in the SQL side, where we see certain columns that's supposed to be numbered or doubles or integers are being identified as strings. So that's vendor ID, the location ID, the payment types, and improvement surcharge. So there's a few other columns that have issues, so we're going to be fixing that. So one benefit of using Spark is the analysis in SQL, we had to write a query to check every max and min for any number columns, right? In Spark, there's a quick way of doing that that's called describe. So you call the data frame and says describe, and it will tell you all of general statistics of the data. It shows you all the record counts, the mean, the max, the medians, and the standard deviations. We do see, for example, 0 to 9 passenger, the trip having 0 amount, all the long and lats are undefined. Did see the negative fare amounts and the 623,000 as well.
To the person with the $600,000 thing, did they tip?
Alright, future Wilson here. As I was editing the video, I noticed I answered question incorrectly. So I wrote this new query which shows 623,000 fare amount. We want to see if this is a legitimate record. So let's have a look. First thing we notice is that there is a passenger and there's a travel time, which is a good start. Didn't travel very long, as they were only in the cab for about 20 minutes time, which is a little bit interesting that it costs so much to be on a 20-minute trip. We noticed this person did not leave a tip. It's hard to think this is a real record given the amount of time they were in the cab, and there was no tip paid as well. So the next checks that we looked at earlier, for example, the pickup time versus the drop-off date analysis that we did, we can write the exact same query. Essentially, we are telling it to filter the data out that are finding under this condition and count them all up. And this will be the result that we have. So we have 6,289 records that are to the invalid space. So the next analysis we can do is we can apply statistics on the fair amounts. Is what are the outliers of the data, right? We use this function called percentile, which essentially, if we standardize all the data, what are the 0.15% of the data on either side of the scale that might be not valid data, right? So in this case, they say, okay, anything that's lower than $2.50 or as much as $75, anything lower that range and above that range is kind of what we call outliers. So data that might not be accurate. Statistically speaking, majority of our data falls between $2.50 and $75. Now, with all of that, we're going to start cleaning our data. So this including the passenger count has bigger than 0, the trip is bigger than 0, we have drop-off date is bigger than the pickup time. The fair amount that we just saw earlier is also applied. So instead of fixing the amounts to be positive and less than $1,000 or something like that, now we can say, well, statistically, this is a good representation of your data.
We'll get 95 or 97% of our data, ignore these outliers, but the $600,000 bill won't be polluting or skewing the Thursday's
trip. Yeah, exactly.
Cash.
So we probably is equal the amount of all the regular.
Yeah, or more.
Yeah. So there's about 186,000 records that were having issues. We know this is the starting number of the record, and we subtracted out what we written out, right? Now we're going to write the data out. So we're going to create a database, as we talked about the lake database, and then we're going to exclude any columns that we don't need. So in this case, the geolocations, and we're going to cast all the data as you will see in the SQL side as well. And we're going to write this out into the lake database, into this specific table location.
So the stuff you've done so far has been in memory, and your data frame clean lives in memory.
Yeah.
But now we're going to persist it as a table so you can come back and see it tomorrow.
Exactly. Yeah. We can read the data and pull out the last 10 query. Now, a lot of the analysis we're doing right now is one column, max and min and things like that. So one of the analysis we often want to do in machine learning is how does one variable interact with another, right? How do those two data correlate, for example? So this is what Matplotlib and Panda, we are able to do that using the scatter matrix. So we are comparing the trip distance with the fare amount. So you would normally expect the further you go, the more it costs, right? Now you do notice that from the trip distance is the one on the top, the fare amount is the x-axis in this case. So we do see there are some outliers here where we're going very far with not very much amount of cost. So this is interesting to know because you might have additional outliers you want to check that are not standard in your day-to-day check that you have.
I suppose in this case it's easier to see that in a chart like that than it is in raw numbers.
Yeah, definitely. So now we're jumping back to the SQL side, the last part of the demo, and we want to highlight the fact that we're accessing the lake table, even though we're on the SQL end of. So we can use the lake database, which I call it just the Spark DB, and then we can run the query to check the data. Now remember, this is all initially was done in Spark, right? But SQL has access to it. And it's important to know that because the business users, they want to access this data, they can connect to the serverless SQL endpoint and interact with this data using SSMS or Azure Data Studio, for example. We can do the same query to draw the chart as well. In this case, I didn't build a view on top of it. Again, you can easily add to a view to give you the same results. So that's the end of the demo. So I'm just gonna do a summary and then we can do a quick Q&A before we end the call here. So after what we went through here, in data analysis, we have to retrieving the data, analyzing the data, and cleaning our data. We need to make sure our data is accurate and relevant for our business to avoid any reporting issues down the road. In Serverless SQL, we can execute all the traditional SQL command that we have, including things like creating table and views, but we need to do it in an external table in this case. For Spark, we have a much richer tool and library to do complex analysis where it will be quite challenging in SQL to do. The lake database that we created at the end there can be accessible by Serverless SQL, which is very important for our business user especially. So regardless how you go about it, the clean table is really what the business user should be accessing and checking out, and apply more rules if we need to do any validations and checks. In summary, really, Serverless SQL, Serverless Spark provides us an easier way to work with big data technology, the data that's stored in the storage account, without having the need of us managing a lot of the infrastructures ourselves. And finally, the link to my GitHub repo is available now, so if you guys want to go take a look at that. With that, we'll jump to questions.
Well, thank you.
Oh, welcome.
So in terms of backup, so once you've done the serverless Spark, you've got your clean data stored in the database. Does somebody need to specify that for backup? Will it live forever?
Yeah, that's a great question. So when you drop a table in Spark, it will remove the data. For external table created in SQL, the data will remain in storage after the table is dropped. So there will be no data loss in this case. So you got to be careful that any of those scenarios, you be mindful that you don't, easily drop the tables, as that will be erased. In terms of backup, you could define the backup through the storage account, define soft backup, define disaster recovery backup if you need to as well. That's all handled.
The question you've got is, if you do it one way in SQL, you've got to be careful because you've taken up the space and it's sitting there, as against in Spark where it's gone if you don't do something about it.
Yeah.
Okay. And so I'm thinking about reproducibility, and if we're building, I don't know, reports for a board or regulatory filings, you need to be able to recreate the process. I assume you can save the Entract notebooks and even automate them so that they could run.
Yeah, so that would be the next process. So the business says, oh, this is awesome, this is exactly what we want. Then you would formally build an engineering process of that, and that's the data pipeline, the scheduling of the events, and all of the notebooks and stuff like that will have to be coming into play, and write all those fail messages out, for example, that you mentioned earlier as well, Brent. So yeah, a lot of things still need to be done, but this is kind of the first step to get started, get you on the right foot.
Yeah, that's awesome. And in terms of costs, you're paying under the Spark, you're just paying for the compute and a little bit for the storage.
Regardless of the scenario, you pay for the storage because the data stores in there. Comparison between compute and storage, the storage cost should be relatively minimal. In the Synapse case, you pay for the cluster. So I had a small clusters of 3 compute, identifies a small workload. You can also have a very big workload. So that really depends on the type of clusters you use, the VM you use, that will drive the determination of the cost. For the serverless SQL, again, that's all based on the volume of data that we process.
Cool.
Okay.
Thank you.
You're welcome. So thank you for having me here. Thank you for everyone for attending as well. So special thanks to Brent, Taz, and Chris for making this event possible. So this is my LinkedIn QR code if you guys want to add me, and thank you and have a great afternoon.